All right, let's wrap up this chapter with our last macromolecule, nucleic acids. Uh, this is going to be the organic molecule upon which all life depends. All life depends. These are going to be our instructions to make our proteins. So nucleic acids contain a lot of carbon, hydrogen, oxygen, nitrogen, and phosphorus. The monomer of nucleic acids is going to be the nucleotide. Nucleotide. Uh, the polymer, if you put a lot of nucleotides together, you get a polymer called a nucleic acid. Nucleic acid. Right? Which is, again, a long polymer of nucleotides. And when we put a bunch of nucleotides together to make a nucleic acid, we do that via dehydration reactions. Dehydration reactions. All right. A covalent bonds between the sugar of one nucleotide and the phosphate of another nucleotide. And that's what you see here. When you have these covalent bonds between sugar of one nucleotide and the phosphate of another one, you create something called a sugar phosphate backbone. So this creates a sugar phosphate backbone, which is the backbone of your nucleic acid. And this is, maybe I talked too soon about this. There you go. This is going to be our sugar phosphate backbone. Okay, so you can see I'm only getting all the sugars and all the phosphates. This is going to be the sugar. This is going to be the phosphate. All right, and that itself all linked together is the sugar phosphate backbone. So nucleic acids, what do they do? What's their main function? They're going to store, well, let's say store and transmit genetic information, right? Uh, it's said to be hereditary, hereditary, meaning that it is passed on from one generation to the next. Okay, so that's what nucleic acid is. So let me just go back here really quick to my diagram. This is going to be the sugar phosphate backbone. You already know that. And these are going to be the nitrogen containing bases. And we'll talk more about it in a second. Okay, base, and this is another one, and this is another one. And they're going to be kind of sticking out. Okay, they're going to stick out. Stick out. And eventually they stick out, and eventually they will do hydrogen bonds to stick to find its complementary base. Okay, to bound to its complementary base. But we'll see that in a second. So nucleic acids, especially the DNA, they're going to provide instructions to build proteins. Two types of nucleic acids. We have DNA and we have RNA. Right? DNA is deoxyribonucleic acid. Okay, and RNA is just ribonucleic acid, a ribonucleic acid.